You step out of a hot shower and the mirror has vanished behind a pale white veil. It looks like smoke, yet nothing is burning. The glass is not suddenly dirty, either. What you are seeing is ordinary water reorganizing itself at a boundary your eyes normally ignore. Hot shower water evaporates and adds invisible water vapor to the bathroom air. The warmer air can contain more vapor than cooler air. Within minutes, the air near the shower becomes warm, humid, and very close to saturation. The mirror usually begins near the temperature of the wall and the rest of the room. When warm, humid air reaches that cooler glass, the thin layer of air touching the surface loses heat. The important action happens inside this boundary layer, not across the whole bathroom at once. Cooling raises relative humidity. If the boundary layer air reaches its dew point, it can no longer keep all its water in vapor form. Some molecules leave the gas and become liquid. This phase change is condensation. Condensation does not begin as a smooth sheet. Microscopic droplets form at small imperfections, dust particles, and favorable nucleation sites on the glass. At first, they are far smaller than the drops you can easily see. A clean mirror sends light through the glass and back from its reflective layer in an orderly way. Thousands of curved water droplets bend and scatter that light in many directions. Your reflection has not been erased. Its organized light has been scrambled before it reaches your eyes. As humid air keeps arriving, droplets collect more water, touch their neighbors, and merge. The fog becomes denser. Eventually, gravity wins over surface tension, and larger drops begin to run downward in winding tracks. Touching or warming part of the mirror can keep that region above the local dew point. Air beside the warmer patch does not reach saturation as easily, so less water condenses there. Heated bathroom mirrors use exactly this temperature advantage. Wiping removes the droplets that already exist, so the reflection returns for a moment. But if the glass is still cool and the air is still humid, the same boundary condition remains. A new population of droplets begins forming almost immediately. An exhaust fan removes moisture-laden air and replaces it with drier air from elsewhere. Lowering the amount of vapor lowers the dew point. If the mirror stays warmer than that new dew point, condensation slows or stops. Opening the bathroom door can mix humid air with drier air from the home. It is not magic, and it is not always enough, but it reduces the local vapor concentration. The mirror clears when evaporation from the droplets becomes faster than new condensation. The beads on a cold drink, dew on grass, fogged eyeglasses, and a bathroom mirror all share the same mechanism. Moist air meets a surface or region cool enough to cross the dew point, and invisible vapor becomes visible liquid. The hotter and longer the shower, the more vapor enters the room. The colder the mirror, the faster its boundary layer reaches the dew point. More vapor plus a colder surface produces earlier and heavier fogging. The mirror is therefore a simple detector for a limit in the air. It reveals the moment local cooling pushes humid air beyond what it can hold. The white veil is not smoke and not dirt. It is a map of heat transfer, saturation, and light scattering drawn in water.